All right, welcome to the video on matrix multiplication and matrix identities. We'll discover those as we are practicing multiplication. So objective for today is I can look for and express regularity in repeated reasoning, okay? All right, so here's our opener. If you want to go ahead and see if you can recall how to do these, especially A and B should be nice and easy, but C, on your own, go ahead and pause the video, try it on your own. If you need help with C, then I'm going to show how to do all these just because it was a quick lesson yesterday. Okay, so let's go ahead and look at how to do each one of these. So first off, it says perform the indicated operation, no calculator. So I have a scalar of -2, so I'm going to multiply the first matrix by -2, and then I'm going to add it to the second matrix. Notice that both of the matrices are 2 by 2s, so I am able to do this. So if I multiply the first matrix by -2, I'm going to write down the new matrix. This you don't necessarily have to do. You could all do it in mental math if you'd like, okay? But I'm going to then add it to this matrix right here, this 1, 1, 1, 1, 1, 1. Okay, so multiply every entry there by -2, so I get 4, -10, -10, -18, and then now I can add these two 2 by 2 matrices. So my resulting matrix is going to be a 2 by 2 matrix, and I have 5, -9, -9, -17, and that's my resulting matrix. Okay, this one right here, I'm going to multiply the second matrix by 3, and then I'm going to subtract the 2 matrices. So I'm just going to copy down this matrix right here exactly how it is because it's not changing until I subtract it from this. And then I have a choice. I can either multiply the second matrix by 3 and then subtract, or I can multiply the second matrix by -3 and add, which is what I'm going to do. All right, so -3 times 0 is 0. -3 times -4 is positive 12. -3 times positive 2 is -6, and then -3 times 4 is -12. And now I can just add them. All right, so I get a 2 by 2 matrix with resulting entries -3, 13, -2, and -7. -3, 13, -2, and -7. All right, lastly is the multiplication one. Remember, in order to multiply 2 matrices, I need to know the dimensions. So this is a 2 by 3, and this is a 3 by 1. In order to multiply them, the inner dimensions have to match, or the columns on this matrix and the row head, that matrix have to match, which they do. My resulting matrix is going to be the outer dimensions, so it's going to be a 2 by 1. So I'm going to start by making enough room for 2 columns, okay? And then in order to do that, you're going to multiply this row times this column. You're going to do what's called the dot product once again. You're going to multiply 3 times 4, which is 12, and add 4 times 5, which is 20, and add 1 times 2, which is 2. Okay, use this instead. So I'm going to multiply this row times this column, row 2 times column 1 to get my row 2, column 1 entry. I'm going to multiply -2 times 4, which is -8, plus 0 times 5, which is 0, plus 3 times 2, which is 6. And remember, my resulting matrix is a 2 by 1. So if I accidentally thought this was a 2 by 3, I should catch myself here. All right, so I got 12 plus 20, which is 32, plus 2, which is 34. And then -8 plus 0 plus 6 is -2. Okay, so today's lesson is pretty simple, and then I'm going to have you practice the rest of the period. So make sure if you are absent today, you are watching this video, trying these, and then doing the round table that's available. All right, so it says multiply the following 2 matrices. If you want to pause the video and try it on your own, that's great. All right, I'm going to do row 1 times column 1. I should say this is a 2 by 2 times a 2 by 2, so it is possible, and I get a 2 by 2. All right, so I have 1 times 8, which is 8, plus 0 times 2, which is which is 0. And then I'm going to do row 1 times column 2. That's 1 times 7, which is 7, plus 0 times 3, which is 0. And then I'm going to do row 2 times column 1. 0 times 8, which is 0, plus 1 times -2, which is -2. And then row 1 times column 2, 0 times 7, which is 0, plus 1 times 3, which is 3. So the resulting matrix is 8, 7. It's a 2 by 2. 8, 7, -2, 3. Okay, now if I erase this right here, you should notice that we got the same matrix that we started with on the right there, right? That 2 by 2, okay? Now we're gonna switch the order of those two. So we're gonna switch this and this, notice right here. We're gonna do this matrix times this matrix and see what we get. Okay, so once again, we can do it. It's a 2 by 2 times a 2 by 2, so we get a 2 by 2. Row 1 times column 1. Right, row 1 times column 1. So that's 8 plus 0. Row 1 times column 2, that's 0 plus, sorry, my brain, I looked at something I shouldn't have. I have 0 plus 7. I'm distracted. All right, row 2 times column 1, that's -2 plus 0. And then row 2 times column 2, that's 0 plus 3. All right, so for this, we get the same exact answer, 8, 7, -2, 3. So once again, if you can compare this, if you can, I don't know why I said if you can, if you compare this, you get this matrix that you started with, okay? So let's figure out, I've said it already for the name of this unit, this section, but let's figure out what that matrix is called. And when I say that matrix, I mean this matrix, which is the same as this matrix. What's it called? Now to think about what it's called, I multiplied the matrix by that matrix and I got the same matrix I started with, right? So that's called an identity matrix. So in math, as a reminder, identity is an item which does not change anything when it's applied. So in this case of real numbers, in the case of real numbers, identities are identified by their operation. So what do you think that is? So what would the additive identity be? So I mean, like if you had something, a number, right? And what would you add to it to get the exact same number? So the additive identity is 0. And what I mean by that, for example, is if you have 5 plus 0, you still get 5. You still get the same number you started with. So that's the additive identity. Or if you did -2 plus 0, you still get -2, so on and so forth, right? What is the multiplicative identity? It's a hard word for me. Okay, so what number do I multiply a number by to get the same number I started with? 1, right? So that's if you had 5 times 1, you still get 5. Or -8 times 1, you still get -8, and so on and so forth, right? So what about matrices? We have the additive identity versus the multiplicative. I can't say that word, you know that. Let's do the multiplication one, which we've already done. So the identity matrix is that if you multiply, if it's a 2 by 2, it'd be 1, 0, 0, 1. But what if it's a 3 by 3, right? So what you should notice for the pattern here is that there are 1s on this diagonal that goes from upper left to lower right, and then there's 0s everywhere else. So this would be a 0 here, a 0 here, a 0 here, a 0 here. And that goes on and on forever this way. This goes on and on forever this way. I don't know why I put arrows on that. It looks weird. We can have it stop. Or if I wanted a 4 by 4, there'd be 1s here and 0s here. All right, this is the identity. So that's how it's gonna look, okay? You have 1s on this diagonal right here. These are all 1s, okay? And then 0s will continue this way. 0s will continue this way. 0s will continue this way. It's hard for me to show that 0s continue this way because there's a 1 right there, but 0s continue this way and this way and this way and this way. But the 1s are on the diagonal, okay? So if it's a 5 by 5, it'd have 5 1s in it on that diagonal and 0s everywhere else. If it's a 2 by 2, it's had 2 1s in it on that diagonal and 0s everywhere else. Okay, that was a long explanation of that. The additive identity would be what matrix do I add to a matrix to get the same exact matrix. So if I had a 2 by 2, let's say, and I wanted to add something to that, another matrix to that to get the same exact matrix that I started with, okay, what inputs would it have to be in that matrix? It'd have to be all zeros. So a 2 by 2 would be 0, 0, 0, 0. A 1 by 1 would be just 0. A 3 by 3 would be 0, 0, 0, 0, 0, 0, 0, 0, 0, all zeros. So that's the additive identity, and this is the multiplicative identity. Ooh, I think I said it right. Okay. All right, so that's it for today. Just knowing that that's what happens and then practicing multiplication. Go ahead and try the round table.